Hello, and welcome to application session 2 of this Introduction to Linear Algebra with Wolfram U. The topic for this session is economic models. So let's begin with a brief overview of the session. So economics is concerned with the production, distribution, and consumption of goods and services. Now, economists, the people who actually study economics, will often use mathematical models for the analysis and prediction of economic behavior. So, for example, if you do decide to study economics as a career, then you should probably learn linear algebra and other branches of mathematics to be prepared for that subject. So, in this session, we'll talk about a model due to Leontief, for which he actually won the Nobel Prize, and this model is called the input-output model. Now, the reason why that's interesting for us is that in practice, this model requires the solution of a large system of linear equations. And that was a technical barrier for him at that time, but today, large linear systems of this type can be solved very efficiently using the Wolfram language. Okay, so let's begin with the Leontief input-output model. So let's say you have an economy and there are n sectors that produce goods and services. And there's just one more sector called the open sector, which does not produce goods and services, but only consumes them. So here's a simple picture. You got three sectors that produce manufacturing, agriculture, utilities, and an open sector, which you can think of, let's say, as being a kind of export sector, which only consumes the goods and services produced by the other three. Now, of course, each producing sector itself will create an intermediate demand by consuming goods and services produced by other sectors and itself. And the open sector itself will create a demand for goods and services from all producing sectors, and that's called the final demand. So we have the intermediate demand and the final demand. And according to the Leontief model, the production equation for producing goods and services given by production equal to intermediate demand plus final demand. Okay, so now let's try and rewrite into matrices. So recall from the previous slide that the production equation is production equal to intermediate demand plus final demand. And so let X be the production vector for the sectors and D be the final demand vector from the other sector, that's the open sector. And let's say C is the matrix whose columns represent the units of good consumed by a particular sector. So recall that each producing sector will itself consume some goods and services. So this matrix C is called the consumption matrix for the economy. And so now the equation over here can be written in a rather simple way as X, the production vector, equal to C times X, because that's the consumption matrix over here, plus the final demand. So that's the matrix Leontief input-output model. Now, having put that down, the next question is, how do we solve that equation? So here's the matrix equation. And we begin by letting I be the identity matrix of order n, where n is the number of production sectors. So now I can put that as I dot x, I times x, equal to C times x plus D. You move the C times x on the left-hand side, like I've done over here. You factor it, and then assuming that this matrix over here is invertible, you then get a nice formula for production vector as x equal to the inverse of I minus C times D, the final demand vector. So that's the final solution for the input-output model. So as an example, let's say you've got three sectors again, manufacturing, agriculture, and utilities, which are producing goods and services. And suppose that the consumption matrix is over here. So it's got fractions over here in each column. And suppose the final demand vector for the economy is given over here, the D. So then you can quite easily compute the answer for the production vector by using the formula from the previous slide, and you get back an answer, but it's in decimals, so we round it off because you want to manufacture whole numbers of things. So then the manufacturing, agriculture, and utility sectors must produce 254 units, 190 units, and 129 units respectively to meet the final demand and their own demand. Okay, so when Leontief put down his model originally, he actually had a system of 500 equations, 500 unknowns. But at that time, it was really hard to solve that system, so he reduced it to a system of 42 equations and 42 unknowns. And even this system took 56 hours to solve using the computing technology available at that time. So that's a long time for solving the system. But today, we can solve such systems very quickly using the Wolfram language. So for example, here is a system which I'm setting up, which is going to have 500 equations, 500 unknowns. And I try and compute the formula for x from here. And before you can say input, output, the calculation is done. Now let's check that the vector actually has the right length. It's got 500 length, which is correct. And then you can check that it satisfies the equations by basically taking everything on the left-hand side. And then this over here is required to make sure that the numerical errors get kind of chopped off. But if I do that, I get back a nice 0. It says the solution is correct. And so that's the end of this session. And the main point is that in this session, you have learned about the Leontief input-output model in economics. Now, this model requires the solution of a system of linear equations that could be quite large in practice. And the other point is that large systems of such linear equations can actually be solved very easily using the Wolfram language. Now, as a very last remark, I'd just like to say that most economic models make assumptions that may not be realistic, but they're still used very much for comparison year to year, etc. And they're actually very widely used and a common practice in the economics community. So I'll stop over here. Thank you very much.